This conference will now be recorded.
Okay, good morning, guys. In today's session, let's start about understanding a concept called typecasting. Okay, it's a simple concept and which is very powerful concept and extremely useful concept as well. Okay, it's very simple. Typecasting means converting the data type of one variable to another. I'll repeat this point. Converting the data type of one variable to another is called as typecasting. There is a variable with one data type called int. I will convert it into long, right? I have a data type with something called byte. I'll convert it into int. I'll convert it into short. So like this, converting the data type of one variable to another data type is called as typecasting. It is that simple, right? So firstly, you should understand the definition of it. So what is the meaning of typecasting? Converting the data type of one variable to another. Converting the data type of one variable to another is called as typecasting, right? So in typecasting, there are two categories of typecasting. Just observe here. I believe that you're able to see my desktop. So let me open an image for you guys. Just observe this, guys. Right? This is called typecasting. In typecasting, what is that I said? Converting from one data type to another. That is called typecasting. Closely observe how many categories of data types are available in Java. How many categories of data types are available? Two categories of data types are available in Java. What are the two categories of data type? So one is called primitive data. One is called primitive data. So the other one is called as non-primitive data, right? So primitive data type, another one is called non-primitive data type. So obviously converting from data type of one to other is called as typecasting. Hence there are two types of typecasting. One is called primitive typecasting. Another one is called non-primitive typecasting. Easy. So in primitive typecasting, we have two again concepts. One is called widening, narrowing. Similarly here in non-primitive, again we have two things. One is called upcasting. Another one is called downcasting. All right. These two, widening, narrowing, is not important concept, not greatly important concept, but upcasting and downcasting, extremely important concept. Please observe, this is extremely important concept. Okay, very super important concept. But the first one, that is called primitive typecasting, greatly not important concept. Done. So let me first explain you this primitive typecasting, though it is not important, but as a subject we have to understand it. Okay, not important, but still let's understand it. Okay. Let me start explaining this. So now purposefully I have paused the video now. Purposefully have paused the video, so you will be able to see only my bigger screen now, right? So let me open this, some diagrams that I do have here with me. Please observe this. So observe this diagram. We have two categories of data type in Java. Firstly, you should understand what is the meaning of data type, right? What is the meaning of data type? Whenever I define any data, let's say I have a data called 33. This is my data. So you know that as a human that it is a number and it is an integer number. All right. So how computer knows that it's an integer number, or how Java knows that it is a number which is an integer number? So you have to describe the data. We have to describe the data. How do you describe the data? So first thing is that you should describe what category of data it is, or what type of data, or what category of data. So when I say what category of data, there are many things here. There are many things which comes into picture here. The first one, is it a number? Is it a number or not? Or not? Is it a number or not? First thing. Let's say if it is a number, what type of number? Here again, two things. Here, two things. Yes or no. If it is a number, then what type of number again? Right? Is it a decimal number or integer number? Is it an integer number or a decimal number? Okay. So if it is an integer number, so we have, you understand now? If it is again, okay, if it is a number or not, if it is not a number, what type of data it is? Clear? Like this, we have to describe the data, right? Then while describing, okay, this is the first thing that you should know about this. This is the first thing that you should know while describing. Are you clear? Second thing, I just write it here. Second thing, we also have to describe what is that, sorry, I'll erase it. Second thing, what I should describe here is this. How much memory is required for this data? To store this data, how much memory is really required? Do you need 1 byte of data? Do you need 2 bytes, 4 bytes, 8 bytes? How much data, how much memory that you need? So that is what I have to describe, right? The third and the last one, the range of data. When you say number, it is in which range? Range of data. These are all the three things which are described by, please understand, these are all the three things which are described by data type. So data type is nothing but one feature of a programming language. I'll repeat, data type data type is one of the feature of a programming language which is used to describe the data, right? When you want to describe a data, it describes few things: what type of or category of data it is, whether it's a number or not a number. We call it as here, we call it as not a number, whether it is a number or not a number. If it is a number, what type of number, right? How much type of data, how much memory is required to store the data, and what is the range of data? So these three things are described by using something called data type. Are you clear? Again, in this data type, there are two categories of data type. What are the two categories of data type that we do have? The first one, the first one is called primitive data type. The second one, the second one is called non-primitive data type. Non-primitive data type, right? So we know already in Java what are the primitive data types available, right? We have some of the primitive data types like byte, we have short, we have integer, we have long. Similarly, not only that, we have something called float and then double. Next, there are two data types. One is called char, another one is called boolean. One is called char, the other one is called boolean. So these are all the primitive data types available in Java. What are the non-primitive data types then? Non-primitive data types are those data types which are defined in the form of class. Any class that you write, in Java, that is considered as non-primitive data type. All right. Now, for primitive data type, range of data is applicable, memory is applicable. Please try to understand, memory is applicable, range of data is applicable, and also category is applicable. But for non-primitive, range of data is not applicable and memory is not applicable. So now let us concentrate more on primitive data type and the casting of this primitive data type. What is the meaning of casting with respect to this primitive data type? Now observe. Now try to understand this diagram. For 1 minute I'll pause, or for 10 seconds, 20 seconds I'll pause, go through this diagram and try to understand it. To store a data, which is a number, in number, which is an integer number, What is the meaning of integer number? A non-decimal number. To represent a non-decimal number, that is nothing but integer number, we have 4 data types. One is called byte, another one is called short, another one is called int, the last one is called long. We have 4 data types. Okay, so byte means the capacity of byte is 8 bits. The capacity of byte is 8 bits. Byte can store -128 to +127. This is the capacity of byte. Similarly, for short capacity is 2 bytes. Just for 1 minute, I'm going to even mute the microphone. Guys, I'm clearly messaging saying that I have muted my microphone for 2 minutes because a vegetable seller is shouting here. And still you guys are answering, asking, sir, your voice is not audible. Now I hope now you're able to listen to me, I believe. Okay. Now just observe guys. I develop a program now here. I create a class called as test. I call it as data type test program with a main method. All right. So please observe this diagram. We say that byte, there is a data type called byte, which represents a number, but that number should be in the range of -128 to +127. You may say, when I say byte b1 equal to 120, it works. This is nothing but +120, right? It works. So in the same way, if I mention it as 125, it works. -125, still it works because these are all in the range of this data type. Observe this data. Okay, observe the range now. The range of byte is 127 to -128 to +127. So obviously it's working, so no errors here. Okay, I just say B1, so absolutely no errors here. But if I make it as 130, it's giving an error. Why error? Because this is out of the limit. Out of the limit means 1 byte of memory, that is 8 bits of memory, is not enough to store the data called 130. So what do you mean by this? So technically it is just like this, guys. So B1 is a bucket. This B1 is a bucket. What is the capacity of this bucket? The capacity of this bucket is, the capacity is byte. What is the capacity of byte? 1 byte, nothing but let's say 1 liter. This is 1 liter. Okay. Now, when you store the data called 130, 130 cannot be stored in this. It overflows. 130 cannot be stored in this. This becomes small. So hence, what do you need? You need a bigger bucket. To store the data called 130, you need a bigger bucket. What is the meaning of a small bucket and a bigger bucket? Very simple. Small bucket is having small capacity, 1 liter capacity. 1 liter is nothing but, let's say, 1 byte capacity. So I should go for a bigger bucket. Let's say I go for 2 liter bucket now. When you say 2 liter bucket, it is nothing but 2 bytes, 2 bytes of memory. So understood now? The data type which is capable of having 2 bytes of memory is called as short. So short is little bigger than byte. So you need a bigger bucket of, let's say, 4 liter bucket, 4 liter bucket, nothing but 4 bytes of memory. Then you should go for a data type called int. For this, you should use data type called short. You should use a bigger data type called int. That is a pretty simple differences between integer, short, byte, and long. Right now, observe this. Right, byte is having 1 byte, 1 liter water. Short can store 2 liters water. Int can store 4 liters water. Long can store 8 liters water. So what is the range of data that you can store it in the long? Minus 2 to the power of 63 to plus 2 to the power of 63 minus 1. This is the range of data that you can store in case of long. That's why any bigger data that you want to store, we should use something called long. But remember, all these things is going to store only integer value, but not the floating value. So if you want to store some floating data, then you should use this float. We have something called float, which is having 4 bytes. The bigger to the float is called as double, which is having the capacity of 8 bytes. So float is bigger or double is bigger? Just message me in the chat box, which is bigger now. Yes, it's very simple. Double is bigger than float. Similarly, in this example, which is bigger in this example? The biggest one is long. Next to smaller to long is int. Next to smaller to int is short. Next to smaller to short is byte. Be careful while you mentioning long, L should be in lowercase, okay? Java is case sensitive, it should be in lowercase. Yeah, I hope now you understood. So similarly, what is the capacity of short? 2 bytes. What is the range of values that short can store? Minus 32768 to plus 32767. What is the meaning of it, guys? Again, coming back to this example here, I'm going to take the data type like this. Short s equal to 32,700. 32,700. 32,700 is still in the range of short. Still in the range of short. 32,800. Is it in the range of short? No, because the maximum range of short is 32,767. That is 32,767. Here 32,800, which is bigger than this short. Hence, to store such data, you need to go for a bigger capacity of bucket called integer. Here to store 130, you should use a bigger bucket called as short. Now understood now? You got it now? This is very basics about data types and range of values and all. Now we have not even started discussing what is the meaning of data type. Okay, you SS is asking, sir, I want to store a data which is bigger than long. No, you cannot store that. As a maximum limit that is been given, you can store most any big data in long here. Imagine, yeah, 2 to the power of what is the range of that long? 2 to the power of 63 means it's such a big data. Your system cannot accommodate, your computer cannot accommodate the data which is bigger than that. Please understand it. SS, your computer cannot store the data bigger than that. You want to store the bigger than that means that computer only cannot accommodate that data. Okay, anyhow, let's come back to the concept now. Let's start with something called typecasting. Typecasting. What is the meaning of this typecasting? Converting data type from one to other is called as typecasting. Okay, let's try to understand it, right? Let's see whether you have common sense or not. Think about it. I have a small mug, okay? A small mug. I hope you're able to see my video now. You have a small mug. In my small mug, cameras, observe. I have a mug. The capacity of the mug is 1 liter. What is the capacity of the mug? 1 liter. In this 1 liter mug, this is full, okay? 1 liter mug is full. 1 liter mug is full. Maybe it is filled with the water or milk or beer. It's up to you what you want, right? I have a mug of empty mug, or sorry, a mug, okay, empty mug with 1 liter capacity. Now I'm going to put some water into that. So how much water is there in this mug? 1 liter. Now what I'm going to do, I'm going to take another empty mug. Another empty mug. The capacity of that mug is 1 liter. It's empty mug. So can I pour the water from this mug
Sir,
to this?
nothing is visible.
Is it?
Yes,
You're
sir,
visible, sir.
not visible.
Video is not visible.
Yes,
No,
sir,
no,
not
your video.
visible.
Okay. Many students are saying it's visible.
No,
Yes, it is
sir,
visible.
Yes, sir, not
not visible.
अरे यार around कम से कम 15-20
Not
students.
visible, sir.
What is the problem with this? Hold on. I don't know. Hold on. Hold on 1 second, please. At least something is visible now, screen or something now.
Yes, sir, screen is visible.
Okay, fine. There should be some problem with this camera, I believe then. I mean, maybe the, okay, whoever can see me, okay, observe. Whoever not able to see me, okay, fine. You just go through my audio. Okay, I think yes, yep. Network issue, maybe from my side, problem probabilities sometime, right? Okay, I'll continue here. I'll continue. I'll continue now. Mute yourself. Mute yourself. I'll continue. Observe. I'll repeat this entire thing. So I have 1 liter mug, okay, filled with water. Now I have another 1 liter empty mug. Now carefully observe. Okay, I have 1 liter mug filled with water, and the left hand side I have empty mug of 1 liter. Capacity, both mug capacity is 1 liter. Can I put the mug? Can I pour the water from my right mug to left mug? Answer in the chat window. Is it possible? Why possible? Because it is common sense. Correct? So I have one mug. The capacity of this mug is 1 liter filled with some water or something. Now I take another mug. Same, the capacity is again the same, 1 liter. So question is that, can I pour the water from here to here? The answer is yes, perfectly possible. Because yes, of course, the mug is empty. First thing, of course, the mug is empty. Second thing, observe, this is also 1 liter. This is also 1 liter. Are you clear? This is that simple. Now observe Eclipse. Now I have int I, I have variable called byte b1 equal to 120. So now I'll take one more variable called byte b2. What is b2? It's a variable. This b2 is nothing but an empty mug. So can I assign b1 into this? Now what am I doing? I'm assigning b1 to the b2. Now if you print b1 some space plus b2, observe the data. Observe the output of this program. Both are 120. Can I call it as variable assignment? This is called variable assignment. What am I doing? Diagrammatically representing. I'm just I have one variable. I have one variable called p1, storing the data called 120. I'm assigning, because assignment works from right to left. Assignment works from right to left. I am taking one more variable called b2, assigning the data from b1 to b2, from right to left. But observe, b1 is byte. The capacity is 1 liter, nothing but 1 byte of memory. Similarly, b2 data type is also byte. b2 is also byte, and the capacity of b2 is 1 liter, nothing but 1 byte. Since the capacity is same in both the cases, it is not at all an issue. I think this is pretty simple. This is no great programming, only simple common sense. I assume that you understood now. All right. Now, what I'm going to do, let me take another example. Observe. Now, I have 1 liter mug. I have 1 liter mug. This is not a programming concept. This is simple common sense. Okay, 1 liter mug. What is the capacity of this? 1 liter mug. Let's say the name of this mug is, let's say B1. Okay. Now I'm going to create. I'm going to take another mug which is bigger than this. which is bigger than this. How much bigger than this? Let's say the capacity of this mug is 2 liters. 2 liters the capacity. Now this mug is filled with water. Let's say the name of this mug is B2. The name of this mug is, let's say, or B2, or rather than calling it as B2, I'll call this name as S1. I'll call this mug name as S1. Now question is this: can I take the water? Can I take the water and this is filled with some water, right? Can I take this and pour this into this? Is it possible to store the water which is present in B1? Is it possible to store it in S1? Answer me. Okay, so most of you are answering yes. Why? How yes? Question, how yes? Because when you are able to store in 1 liter mug, of course, S1 is bigger than B1, hence you can store it, correct? The capacity is more, correct? Larger capacity. S1 is having larger capacity. We can perfectly store it. Absolutely fine. Correct? So now imagine, now I'll start writing the program. Observe. Now I have 1 liter means what? 1 byte. 1 liter means 1 byte, let's say. So who is having the capacity called 1 byte? Byte. Let's say byte B1 equal to 127. 127. Now I'll take S1. 2 liter means, think that 2 liter means 2 liter means 2 bytes, okay? 2 liters means 2 bytes. Who is having 2 bytes now? Short. So it is just like this. I'm having something called short S1. Short is bigger than byte. Observe this diagram. Short is bigger than byte. Observe this diagram. Short is bigger than byte. Byte is having only 1 byte, but short is having 2 bytes, 16 bits. Okay. Now coming back to this. Short is having bigger than that. Okay. Can I assign? Yes, you can assign. It means to say you can write the code like this: short S1 equal to P1. So now observe, this is called typecasting. Typecasting. Why typecasting? You are converting from one data type to another. What is the meaning of it, sir? Data type of B1 is byte, right? You are assigning that into whom? S1. The data type of S1 is short. You are converting byte to short. So you are converting byte. This is your byte, and you are converting it into short. Short is bigger or smaller? Short is bigger than byte. So this is called widening. What do you call this concept as? Widening. Observe here, you have to consider from left to right. Why left to right you have to consider? Because assignment happens from left to right, right? So left side is smaller one. Sorry, sorry, I made a mistake. It works from right to left. To it works from, sorry, right to left. Okay, so right side is smaller one, sorry, the left side is bigger one. Then so this concept is called as what? Widening. Data casting, typecasting, converting data type from one to other. This is called as typecasting. And these data types are primitive, hence it is an example for primitive typecasting. In primitive typecasting, are you widening it? Yes, I'm widening it. So this concept is called widening. So you can ask me question only related to this example, nothing other. Now don't bring me some long double gibble and all. No, anything related to this example, you can ask me question. In the chat box, you can ask me the question. And it is very, very simple question, okay? Simple concept. That's how it works, right to left. That's how it works. Okay. Yes, widening means small to big. Genilia, widening means small to big. Yes. Palash Samantha is asking why widening is required. Let me be very honest. This is one useless concept. In the beginning itself, I answered this. All right. Now Deepshika is asking a question. Vice versa is possible. It depends on data. Vice versa is possible. It depends on the data. That's called downcasting. Deepshika, that's called downcasting, which I'll explain you after upcasting. Sorry, that's called narrowing, not downcasting. Sorry, that's called narrowing, which I'll explain you after this concept. Prem is asking question. Prem, here is a question. It is Java is little different from C. Okay, please understand. Okay, please observe. I'll explain you some concept. Now stop asking question. First, I'll answer this question, Prem question, which is something interesting. Okay. Now observe. Everyone observe. Let's say I have something like this. Byte b1 equal to 127. Next. Short s1 equal to b1. Right. There are two ways of understanding it. This is your program. There are two ways of understanding it. Observe. For better understanding, I write like this. Okay. I use these colors so that you will understand in a better way. Now observe. So I have something called B1 storing a data called 127. I have another one. Okay. So observe the name of this is B1 and the name of this is S1. In some languages, some programming languages, when you say short S1 equal to B1, it would happen that S1 simply start pointing to B1. S1 may simply start pointing to B1. That could happen in some language, but not in Java. So this is the question that Prem is asking. Sir, does it point to that or does it entirely store? In Java, it works in this way. This is not the way that it works in Java. In Java, how exactly it works? In Java, it works in this way. One is storing 127. Let's say this is B1, right? This is S1. When you say B1 is assigned to S1, try to understand here. I use a better color for assignment operator, right? Let's say I use this color. When I assign here from B1 to S1, what exactly happens? This data is copied to this. So this also stores a data. This also stores a data called 127. This also stores the data called 127. Are you clear? So S1 is nowhere pointing to B1. Rather, S1 is also storing 127, B1 is also storing 127. And this is how it works in Java. Prem, I answered your question. This is how it works in Java. Next, Satyam, if the data is bigger than byte, then it won't assign B. Then how it would assign further? That's why I who has asked this question? Satyam, that's why I asked you to your question should be specific to this example because I have just introduced you guys with only one example. I have not explained this concept. There are many more examples I'll explain you right now. Okay, Pratap, can we convert short to byte? Is it possible, sir? Yes, it is possible. It depends on what is the data stored in what is the data that is stored in a variable of short. Pratap, that's called narrowing concept, which we'll understand. Mukul Sharma, I'm explaining only primitive data type. Non-primitive, I'm not even started. Prem is answering, yes, I understood. Thank you. Any other questions related to this example? Please ask me. This is not greatly important concept. Okay, it's not that greatly important concept. Basically, we never convert from one data type to another data type in project. Okay, super. I'll just move on. Okay, thanks for answering. I'll just move on now. Super. Thank you very much. I'll move on now. Observe this. Now I have byte. Okay, fine. One strategy I'll teach you. Whenever you really want to assign from one data type to another, listen to me. If you want to assign one variable to another, you have one variable. Let's say you have a variable called. Let's say you have a variable called variable one. Right? You have a variable called variable one. You want to assign this variable to variable two. This is called assignment operator. When you really want to assign one variable to other variable, when you want to assign from one variable to another variable, one very important thing you should understand, one rule I'll teach you, the left side data type should be greater than or equal to right side data type. Okay, the left side data type should be greater than or equal to right side data type. Never ever forget this rule. Okay, never forget this rule. Very important, the left side data type should be greater than or equal to right side data type. Okay, now observe, this is called variable assignment. I'm assigning here, I'm assigning b1 to, observe, I'm assigning here b1 to b2. Observe the data type of b1, byte. Observe the data type of b2, that is also byte. So you are assigning byte to byte works because left side is same as right side. In this case, it works. It perfectly works. In the same way, even if I write the code like this, which is bigger than byte? Short. Short S1 equal to B1. Observe this. In this code again, data type of B1 is byte, that is right side. What is there in the left side? S1. What is the data type of S? Short. Short. Left side is short, right side is byte. So it means to say, what is there here? Left side is same as short, short is same as byte. No, short is bigger than byte. So short is bigger than byte. It works. The rule says that left side should be same as right side, or left side should be bigger than right side. This is the rule. So as per the rule, S1 is short, short is bigger than B1, nothing but byte. So it works. Left side is bigger than right side. Or even it can be still bigger one. What is a bigger than short? Int I equal to B1, int I1 equal to B1. Or even you can also say int I2 equal to S1. That is also fine. This is also fine. Data type of S1 is, what is the data type of S1? Short. What is the data type of I2? Int. Int is bigger than short, it works. Or even you can say like this, long L1 equal to B1. What is the data type of B1? Byte. What is the data type of L1? Long, hence left side is bigger than it, it works, right? Or you can also say long L2 equal to S1. This works, right? Long L3 equal to I1. This also works, perfectly works. These are all examples for widening. So if left side data type is bigger than the right side data type, it's called type conversion, converting. See, observe this line of code here. What am I doing? Converting data type from one to other. What am I doing here? Converting data type. This data type is byte. I'm converting this into short, right? This is called type conversion or typecasting. In this, these data types are primitive, hence it is called primitive typecasting. In primitive typecasting, you are increasing. Byte is smaller than, byte is smaller, the bigger to byte is short, hence this is called widening. In this example, observe data type of B1. What is the data type of B1 here? Data type of B1 is byte. Data type of B1 is byte. You are assigning it into long. Long is bigger than byte. Yes, very, very bigger than it. Byte is smaller, long is bigger. Hence, this is called a widening or typecasting. Conversion of one data type to another is called as typecasting. In typecasting, we are dealing with primitive data type. Hence, it is called primitive typecasting. In primitive typecasting, you are widening it. This is possible. All right, any more questions? Okay, good. Similar to this, I'll give you one more last example on widening. Then I will explain you narrowing concept, okay? But don't forget that rule. Left side should be greater than or same as right side, okay? So now another small example. I have something called short is equal to 32,600. 32,600. Observe now, short can perfectly store. What is the data that short can store here? Short can store minus 32768 to plus 32767, 32,767. All right, 32,750, let's say. Perfectly possible. Now I can assign it into one more variable called short. For example, I call it as S1. So now I'm going to assign it into S2, short S2 equal to S1. Now observe this. If you print S1 plus some space, just observe this program. Three to 750, 3 to 750. Observe this output. So to explain this concept, it is just like this. You have one variable called short, that is S1, which is there on the S1, which is there on the left side. Similarly, S2 is there on the, sorry, it is there on the right side. How am I getting confused between right side, left side? Come on. Very bad. So I'm assigning from S1 to S2. So what is the data type of S1? The data type of S1 is, sorry, S1 is at the right side, S2 is at the left side, correct? No, yeah, I'm assigning from right to left. So what is the data type of S1? The data type of S1 is short. Data type of S2 is also short. So it means to say here, left side is equal to right side. Perfectly possible. The rule still okay, but it is not called as typecasting because both data types are same. I'm not changing from one data type to other. Data type of yes, this is short, this is also short. Both are same. So this is not called as typecasting. This is simply called as variable assignment. This is called as variable assignment. This is not called as variable assignment. Okay, it is simply called as variable assignment. There is no typecasting here, right? Now, what is typecasting then? Now observe. I'll write the program for typecasting. If I assign this into, let's say, integer I equal to s1, integer I equal to s1. All right. So now what am I doing here? This is called as typecasting. Sure. When I say I equal to s1, s1 is at the left side. Oh, come on, is at the right side. I is at the left side, right? Data type of S1 is short, right? What is there on the left side? The left side is I. What is the data type of I? Data type of I is integer. Now, do you think integer and short is same? Absolutely no. Short is having 2 bytes of memory, right? Integer is having 4 bytes of memory. So obviously integer is bigger one. Integer is bigger one. Short is little smaller one. So this is called typecasting. Converting data type from short to int is called as typecasting. And we are dealing with primitive data types like integer, short. So hence it is called as primitive typecasting. In primitive typecasting, this is wider one because left side is bigger than right side. This is called widening. Okay, this is, you can call it as primitive typecasting. In primitive typecasting, it is called widening. So easy. Understood what is the meaning of widening concept. Okay, thank you. Samiksha, Rinki, everyone are answering. Yes, sir, we understood, sir. I'll have a glass of water. One second. I think these online classes are good, yeah. Aram, so you can slowly explain many things. Hmm? Now I believe these sessions are uploaded in the I believe that they all are uploaded in the website. Is it so? Are uploaded, I think yes. Good. Okay, fine. I'll move on now. Let me explain something called yeah Pratap Singh. Devesh Pratap Singh. Yes, online classes are good, yeah, quite good. It depends on perception. Some students they feel that live classes are better. Someone feel that like online classes are better. It's like yes, sometimes network issues, correct. So and one more thing I wanted to inform everyone because some students asked me in the message saying that they don't have enough network to attend online classes. So can I attend live class once I come back? Let me be very frank. Once you come back to Bangalore, you are perfectly eligible to attend all my class once again. You can attend my class again, absolutely no issue. Are you clear? You can repeat my live classes once you come back to Bangalore. Not now, even if you come after 3 months, you can still attend my classes. Are you clear? This is first thing. You can perfectly attend my class. Or if you feel like, okay, sir, I'm enough with this live class, online class, that's also, it's up to you. Choice is for you. You can attend this class even after finishing online class. If you feel like to repeat live classes, you can do that once you come back to Bangalore. Okay. Now, please observe. Let me now explain to you what is the meaning of narrowing concept. Fine. Observe. I ask you a question, and in this question, this is something related to common sense. Okay, something related to common sense. If you are able to see my video, it's well and fine. Otherwise, also not an issue. Observe. Think about this situation. I give you one mug. Mug capacity is, let's say, 2 liter. Mug capacity is 2 liter. Okay. Try to understand. I give you a mug. Okay. I'll rather than this video because some students are not able to see the video. Hence, what I'll do, I'll write and explain this. Okay. Now observe here. I give you one mug. The mug capacity is 2 liter. 2 liter is the mug capacity. Okay, and I call this mug as um, let's say S1. I call this mug as S1. This is the name of this mug. Okay. Now, but here, the very important thing, water is only half liter. How much water is there? Only half liter water is there. Okay. Only half liter water. Water is only half liter, but mug is bigger mug. Okay. 2 liter is the capacity of the mug, but observe water is only half liter. Now, can I take another mug? Another mug. Okay. This mug called, the mug name is B1. Mug name is B1. Okay. But the capacity of this mug is smaller, only 1 liter capacity. The capacity of this is only 1 liter. Now the question is, can I take this? Can I take this and pour the water from this mug to this? Is it possible? I want you guys to answer. Yes, sir. Super. Very good. So perfectly correct. Here, yes, you all are correct. Correct. Good. Observe. Here, the capacity of this S1 mug called S1 is bigger, I agree, but water is only less, only half liter water. So the funda starts now. Observe. Now what do I do? Please observe, everyone. I consider S1 as this short S1 equal to short capacity is 2 bytes. Short capacity is 2 bytes, okay? When short capacity is 2 bytes, please observe when short capacity is 2 bytes, but I'm storing not even 1 liter water, I'm storing only half liter water. So data is, let's say, 80. Data is 80. What is the meaning of it? S1 is a variable storing a data called 80, right? But the data type is short. Now, I consider this as byte B1. I consider the variable as byte B1. So I have a variable called B1. What is the data type of B1? Byte. The data type of B1 is byte. Are you all clear now? So byte capacity is 1 byte. What is the capacity of byte? 1 byte is the capacity. That's why I represented it as 1 liter. Okay. Now question is this: can I assign B1 S1 to B1? This is the question. Can I assign S1 to B1? Logically, this is possible. Understand it. Logically, it is perfectly possible. But compilation wise, not possible. Why compilation wise it is not possible? Observe. The rule says that, what is the rule here? Pretty simple. The rule is rule, okay? The rule says that left side data type should be greater than or equal to right side. This is the rule. All right. Left side data type should be greater than or equal to right side. What is the data type of B1? Observe. Left side data type B1 is byte. What is the right side data type S1? S1 data type is short. Short is same as byte. Is byte and short same? Byte and short same? Is it same? Absolutely no. Is byte bigger than short? Is byte bigger than short? Absolutely no. Then what is that? The byte is smaller than short. Byte is smaller than short. This is the reality. Hence, if you observe here, okay, what is the ness? Byte is smaller than short, but as per the rules, left side should be greater than or equal to right side. Hence, this is compilation error. Compilation error. But observe, here is the trick, okay? Logically correct. It's logically correct, but compilation wise, it is wrong. Able to understand? Logically correct, but compilation wise, it is wrong. So what is the meaning of it? Logically correct, sir. Logically, now observe this program. Observe this program. Short is storing 80. Can't I store 80? You're assigning, observe, you're assigning 80 to B1. That is nothing but S1 is storing 80. S1 is storing 80. You're assigning that into B1. What is the data type of B1? Byte. Byte can still store 80. Observe the range of byte here. The range of byte is minus 128 to plus 127. So 80 data can still be stored in byte. That's why I said logically it is correct, because byte can still store 80, but compilation wise it is not possible, because compiler always go with the rule. Okay, compiler does not have smartness. Okay, compiler does not have smartness. Compiler is basically it's a software, so it goes with an instruction. What is the instruction given in that software? The instruction given in the compiler software says left side should be greater than equal to right side. That's why Java people made a second rule. Rule number one. Rule number one says left side should be greater than or equal to right side, or by chance if left side is smaller than right side, then you must use something called casting. You must use something called casting. This is called rule number one, right? This is rule number two. These are all the two rules. Understand now? Two rules. In two rules, remember this. Whenever you go for variable assignment, follow these two rules. What are the two rules? The first thing is this: if left side, this is ideally left side should be greater than or equal to right side. If by chance left side is smaller than right side, then you should use casting. But here you should be careful. You should be careful. There is a danger here. What is the danger? Let's understand it. What is the danger? Let's understand. Okay, what is the meaning of the second rule, sir? Observe. Now I have the data like this: short s equal to 10. Short s equal to 10. Now I assign 10. Can I store 10 in byte? Perfectly, yes. 10 can be stored in byte. If I directly write like this, byte b equal to s, you get compilation error. You get compilation error. Hence, what you are supposed to do, you have to assign like this: byte b equal to byte of s. Byte b equal to byte of s. What is the meaning of it? You can think in this way. So this is called casting. This is called casting. Casting means conversion. Casting, simple English meaning is conversion. You are converting s to, you are converting s, nothing but short. You are trying to convert short to whom? Byte. You are trying to convert short to byte. This is called typecasting. This works, this perfectly works only if the data that we are dealing with, if the data is matching with this data type. If it matches with left side data type, then it works. Now observe, logically 10 can be stored in byte because the byte range is minus 128 to plus 127. So 10 is in this range. 10 is within this range, that's why it works. Okay, so this is called typecasting, or this is called narrowing. What is the meaning of narrowing, sir? Observe, right side data type is you are assigning S to B. You're assigning S to B. What is the data type of S? Data type of S is short. Data type of S is short. What is the data type of B? Byte. Right? So now observe, right to left. Observe this right to left rule. Okay, so right side data type is short, which is bigger one. Left side data type is small, so this is called narrowing. This is called as what? Narrowing. Primitive casting. Converting data type from one to other is called as typecasting, and these data types are primitive data type, hence it is called primitive casting. In primitive casting, this is called narrowing. Narrowing works only when the data stored in right side must be in the range of left side. If it is not in the range of left side, gone. Be careful. That's why I say that it is danger. You got to be a little careful here, okay? Now, I'll give you one more example so that you will understand in a better way, still better way. Okay, now observe. Park your question. Hold on. Park your question. Now listen to this example. You will get a better clarity. And after that, still if you have question, you can ask me that question. Okay. Now imagine the case. Imagine this case. I have a mug. Capacity of the mug. Capacity of this mug is 2 liter. Okay. Capacity of the mug is 2 liter. In this mug, I have full of water. Let's say full of water. What is the, how much water is there? Let's say 2 liter water is there. Okay, 2 liter water is there. Now I'm going to create another mug. Now I'm going to create another mug, which is smaller mug. I create a smaller mug, right? This mug capacity is only 1 liter. How much? Only 1 liter. This mug name is B and this mug name is S1. Okay, now observe. Imagine this. You have 2 liter mug with 2 liter water. You have 1 liter mug, empty mug. Now what happens if you pour the water from this mug to this mug? Definitely overflow. What happens? Overflow. Because what 2 liter water is there, 2 liter water cannot be stored in 1 liter mug. Definitely it is overflow, right? So this is logical. This is something related to common sense. Forget about Java. This is common sense, okay? Now, let me explain this concept to you with one program. I have a variable called short S1 equal to 32,000, what is the short capacity? 3 to 7, 6 or 700, 3 to 700. That's a capacity of short if I'm not wrong. Right, short capacity is 32767. Okay, but I'm taking it as 3 to 700. It means to say S1 is a variable. Data type of that variable is short. Short means 2 bytes of capacity. What is the capacity of short? 2 bytes. And full with water, 3 to 700. That's the water. That's the data which is stored there. Right. So now I'm assigning this into. Okay, I'm assigning this into observe B1. What is the data type of B1? So I take B1 as byte. Okay, byte B1. Now S1 is this short S1. I hope now it's better. Color combination matches, right? So now byte B1 equal to I assign S1. I assign S1 here. I assign S1. All right. So this is an error now. This is compilation error. Compilation error. Why compilation error? Compiler is a software which goes with a rule. What is the rule? Rule number one, very important. Rule number one: left side should be greater than or equal to right side. The rule number two: if left side is smaller than right side, you should go for casting. These are all the two rules. All right. So now observe. What is the data type of S1? Data type of S1 is short. What is the data type of B1? Byte. It means to say left side is byte, right side is short, short is smaller than right. Is it applicable now? The rules, check this with, compare this with the rule. Rule says that left side is bigger than or equal to right side, but in your case it is smaller than. That's why you get compilation error. Now let me apply the second rule here. What is the second rule? So what I'll do, I'll write the code like this: byte b1 equal to byte of s1. This is b1. Observe now. This is called as primitive casting, correct? But this is logically incorrect. Please observe this. Logically incorrect. Syntactically correct. What is the syntactical rules? Left side should be smaller than right side means you should apply casting. Now left side, which is left side here to me? Left side is this. Left side is byte. Okay, left side is b1, nothing but byte. Right side is s1, nothing but short. So this is bigger, this is smaller. When right side is bigger than the left side or left side is smaller than the right side, you should apply casting. I have applied for casting. So syntactically, this program is correct. So no compilation error. Why no compilation error? Right syntax. This is called right syntax. Syntax means your compilation rules. Everything is correct. Okay. But logically speaking, please observe, logically this is incorrect. Why logically incorrect? What is the data of this? What is the data stored here? Observe. What is the data stored here? 32,700. The data stored in S1, observe this S1, data stored in S1 is 32,700. Can you store 32,700 in byte? Byte capacity is minus 128 to plus 127. That is the, understand? So this data is not in the range of byte. Hence you get logically, what happens when you store, go back to this example that I had given here. The data is bigger one. That is, you have a 2-liter bucket stored with 2-liter water. If you try to store that or pour that in a smaller capacity of the mug, obviously you're going to the data gets overflow. That's what it happens here. When you try to downcast it like this is called narrowing concept. When you try to narrow, this is called narrowing. Okay, when you try to narrowing, okay, make sure the data must be in a range. What is the data must be in a range? Here you're assigning S1 to B1. S1 is 32,700. That is not in the range of byte. Hence here you're going to lose the data. You're going to lose the data. Be careful. No compilation error, but at runtime you lose the data. At the runtime you're going to lose the data. You get some crazy data, right? Because 3 to 700 cannot be stored in byte. Hence you get some, you don't get exception, you don't get error, anything, but you're going to lose the data. That's why you have to be careful. Okay, this is absolutely useless concept for project. I will repeat, this is absolutely useless concept for project. In the project we never come across this situation. Why the hell I should convert from short to byte? We don't do it, but it is a concept which is derived in Java. Hence, this is not required for project, not required for project. This is only required for written test, or probably in the interview, they may ask one or two questions. Only for that reason, you should understand it, okay? But there is one more thing called non-primitive casting, if you remember. This one, non-primitive casting. This is not important. Primitive casting is not important. Non-primitive is very, very or extremely important. This is extremely important concept, okay? But whatever I have taught now may not be greatly important concept. Now, you can ask me questions if you have in the chat box. Okay, Devesh, okay. Someone here is chatting with the name Q Spaders. What is your actual name? No, Rahul, it will not show runtime error also, Rahul. No runtime error, no compilation error, but runtime you lose the data. Real-time example is, how can I give real-time example for this, Lucky? Whatever I had given is real-time example only as of now. Yeah, jug mug example is real-time example only. Whatever I have explained you with that mug example, isn't it real-time example? Any other questions? So in today's class, we understood what is the meaning of typecasting. I'll just give you the conclusion. Typecasting means converting the data type of variable from one to other is called typecasting. In typecasting, there are two types. One is called primitive typecasting. Another one is called non-primitive typecasting. Today, we discussed about only primitive typecasting, that is converting the data type of variable, which is primitive, from one primitive to other primitive, that is called as primitive typecasting. In primitive typecasting, there are two things. One is called narrowing, another one is called widening. Okay, so this is the stuffs that we have understood. Okay, I'm done from my side. I have explained, like, primitive typecasting, narrowing, and widening, which is not greatly important. But tomorrow's concept, which I'm going to teach you, that is called upcasting, downcasting. That is nothing but non-primitive typecasting. That is extremely important. And if you miss that class, by chance, if you miss that class, you will not understand any further concept of Java. It is right.